So, where do you find the videos again?
Josh. Okay. So yesterday we did our basic probability. Today we are getting into some probability. So we do have only one, maybe two definitions today that we really need to get written down, and then I'm going to give you some formulas. You pull out your formula sheet. You're still going to have that. We are in chapter 5 now, so you notice on your formula sheet it tells you how to calculate empirical and classical, and we are getting into those addition rules today, so a lot of this is just straight from your formula sheet. What you need, the first definition, is mutually exclusive, or sometimes that's called disjoint. Mutually exclusive have no common outcomes. They can't both happen. Okay, so either I give my kid a jelly bean or I don't give her a jelly bean. They can't both happen at the same time. It's one or the other. So this is our addition rule for disjoint events. So if you want, you could just call it so maybe write down addition rule, disjoint events, and then put your formula. The probability of E or F happening is the probability of E plus the probability of F. In other words, if they can't both happen at the same time, to find the probability that one of them did occur, you just add their individual probabilities together. So if I wanted the probability that you got an A or a B on your homework, can you get both an A and a B on your homework? No. So I'd add the probability of an A plus the probability of a B. So in general, or means we're going to be adding things. So let's look at an example. So this probability model shows the number of rooms in different housing units in the United States. Okay, so number of rooms, 1, 2, all the way up to the last case is 9 or more. So can we all agree that you can't have both 7 and 8 rooms? You would have one or the other. Okay, and I give you the probability of each. So verify that this is a probability model. If it's a probability model, what two things have to be true?
It
has to add up to 1 and
has to be between 1 and 0.
Every individual probability is between 0 and 1. So looking at all of those, all probabilities are between 0 and 1. That one's met. Okay, quickly let's add them up. And it does add to 1. So if I put this on a quiz or test and I say verify, you have to tell me that you've looked at both of those things. B, what's the probability that a randomly selected housing unit has 2 or 3 rooms? So the probability of a 2 or 3 is just the probability of having 2 plus the probability of having 3. We're using our formula. So the probability of having 2 rooms is 0.032. Probability of having 3 rooms is 0.093. those together, you get 0.125. So if I asked you to interpret it, there's a 12.5% chance that you have either 2 or 3 rooms in your unit. So C, what's the probability of having 1 or 2 or 3? What do you think I need to do? Add all 3 of those, because there's no overlap. And we get 0.135. Is that okay? There is a second addition rule for when your events are not disjoint. So when there could be an overlap. So like if I wanted the probability of getting an A or getting above an 85%. Is it possible that I could get an A and get above an 85%? Yes, there's overlap in those two. They're not completely separate. That's the general addition. In that case, if I just added the probability of an A plus the probability of getting above an 85%, I've double counted some people. So you have to subtract off what you've double counted. The ones that got counted in both groups individually. Bless you. Alright, suppose that a pair of dice are thrown. So here I just put a diagram showing you if you roll 2 dice, the combinations, a 1 and a 1, a 1 and a 2, so forth. Let E be the event the first dice is a 2, and F is the event the sum of the dice is less than or equal to 5. Find the probability of E or F. Okay, is there overlap here? Can the first dice be a 2 and the sum be less than or equal to 5? Yes, so we have to use the general addition. So probability of the first plus the probability of the second minus the probability of both. Alright, how many combinations are there? Right up, do I have up here? 36, right? You can get that pretty quickly. The first dice there are 6 combinations, second dice there are 6. 6 times 6 is 36, or count how many I have up here. So E, the first dice is a 2. So that's this row right here. So how many times did that happen? 6. So the probability of E is 6 out of 36. F was the sum is less than or equal to 5. So less than or equal to 5. This would be a 2, 3, 4, 5 would work. I wouldn't be able to use 6 though. Here we have 3, 4, 5, that works. These add up to 4, 5, 5. Did I get all of them where the sum is less than or equal to 5? So how many were there?
10.
So the probability of that is 10 out of 36. Minus, how many did we double count? 3. These 3 got counted into both groups, so I have to subtract off that 3 out of 36. So that gives me 13 out of 36, 4.3611. Next. Suppose a single card is selected from a deck. Compute the probability of drawing a king or a diamond. So, probability king or diamond. Could it be both? Yes. So we have to do the general addition. Probability of the king plus the probability of the diamond minus the probability of both. Okay. Do you guys know anything about a deck of cards?
Yeah, somewhat.
Okay. Some years I say a deck of cards and people have absolutely no clue. So a deck of cards is how many cards?
52.
52. How many suits? 4 suits. How many cards in each suit?
Oh, sorry. One. I'm thinking of one of different.
13.
Yeah.
13 cards per suit. Okay. So the probability of king. How many kings are in the deck? 4 out of the 52 cards. How many diamonds are in the deck?
No, 13.
13 out of the 52. How many of the cards are a king and a diamond? 1 out of the 52.
You're messing with the brain here, and I don't appreciate it.
0.307. We all okay with that? Let's do some more. Do you guys want a second to write down this table? I don't know how much you're writing in your notes. I'll give you a second if you want to copy that down. We're going to need to add some things up here. So I'm going to be, these are people in millions. So the first question was determine the probability that a resident is a male. So what am I going to have to do? Add up all the males. So let's just make some totals here real quick. And then altogether, if I add those up, we were looking at 251.3 million. Okay. So the probability of being male, am I going to have any overlap here? Do I have to do anything weird or add up anything? It's just your number of males divided by our total. And we get 0.4875. So B, determine the probability a resident is widowed. What do we have to do there?
Add up the widows.
Add up the widows. So if we add up those two numbers, I get 14.3. the probability of widowed or divorced. Based on this chart, can it be both? No. So we just have to add up the individual. So the probability of being widowed is 14.3. Divorced or you could just add all four of those numbers if you want and divide it by the total. That's fine too when you're reading these from the tables. Bless you. And I get 0.158. 0.1580. Okay, last question for this. Determine the probability that a resident is widowed or is male or widowed. So we'll have to do the probability of being a male plus the probability of being widowed. Can you be both?
Yes.
Yes, so we'll have to subtract off the probability that you were both of those. So male is 122.5, I have 251.3. Widowed, 14.3 out of that. Male and widowed is the 3.1. Do you guys understand how we're doing this? The amount of work you show me on something like this is kind of up to you. I would appreciate, like on a test, at least maybe show me this fraction so I know if you added things up correctly. That kind of gives me an idea of where your numbers are coming from. That's how you could show me a little bit of work. Okay. Yes, sir.
So like on the homework, if we already did like those parts in like A and B, do we have to, or can we just use the decimals with that?
You can use the decimals, but just be aware you might have slight rounding error if you're using those. Alright, we do have one more definition. You don't have to write down everything I have on this slide. So if we're talking about the complement of something, we use, it's just all outcomes that are not in the event. We use this E with a C up at the top. So we calculate it by doing 1 minus the probability of E. So for example, if I gave a test and my event was getting an A, what would the complement of that be? Every other grade. It's basically the opposite. So getting an A, not getting an A. Together they make up everything, so they have to add up to 1. I'll do just a couple more examples and then I'm done. Okay, according to the American Veterinary Medical Association. If you're writing this down, you don't have to write everything. 31.6 of American households own a dog. What's the probability that a randomly selected household does not own a dog? How'd you get it?
I took 100 minus that,
Right.
that's what I got.
They're complements, aren't they? So, the probability of a dog is the 0.316. So the probability of no dog is just 1 minus that. It's 0.684, or you could tell me 68.4%. Either way, they're complements. Either you have a dog or you don't. There's no third option there. The next one is another table. It's a long one though, so don't copy down the whole table. I just want to do a couple quick examples from it. So this tells us travel times for a particular county. I want the probability a resident has a travel time of 90 or more minutes. So I have the frequency for that. What else do I need here? We need the sum of all of those. Okay. So the probability of 90 or more, let's have to take that frequency divided by our total. And again, like the test or quiz, please show me this work, because if you added up the total wrong, all of your answers will be wrong. So show me the work so I know what you're dividing by and I'm not counting every single problem wrong. You get 0.0124. Okay, so what would be the probability that the time would be less than 90 minutes? What would I have to do? Yeah, you could, if you have a lot of time on your hands, go through and add up all of those and do that out of the total. Or you could realize we already know the probability of being 90 or more, so less than 90 is just 1 minus that. They're complements. You get 0.9876. Is that alright?
Did we use any formulas yesterday?
No, not really, just dividing. Okay, last example. The first section of your homework has problems like this. So the first one. Probability of A is 0.4. Probability of B is 0.5. Probability of A and B is 0.1. Find the probability of A or B. This is just practice manipulating your formulas, so I highly recommend just writing out your formula and then plugging in the things that you know. We have A, B, A and B, A or B, so this is just our general addition. From our formulas that we wrote down today, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Do I know the probability of A or B? Probability of A is 0.4. Probability of B is 0.5 minus probability of A and B is 0.1. So probability of A or B is 0.8. As long as you write out your formulas, these are really easy. If you don't write out your formulas, you might struggle on some of them. So the second one, I still gave you A and B, but this time I gave you the probability of A or B to go with it. So if I write out my formula, plug in the stuff we know. Probability of A or B, 0.7 equals probability of A is 0.4, probability of B is 0.5. I don't know A and B. So if I add over my probability of A and B and then subtract my 0.7, we get 0.2. Is that one okay? Last one of the day. This time I gave you the probability of A or B, that's 0.9. Probability of A is 0.4. I did not give you the probability of B, minus probability of A and B is 0.1. So we're just going to solve this equation. 0.4 minus 0.1 is 0.3. Subtract your 0.3 over, and the probability of B is 0.6. Can we handle that? What if I asked you for the probability of not B there? 0.4, 1 minus 0.6. So that is the end of this section. We've got about 10 minutes now, so I want to go ahead and let you get started on your homework and ask questions. This is due tomorrow. We will go ahead and start the next section tomorrow. So let me know if you need